Hi. In this video I will demonstrate the building the simulation model for the Brock Information Desk. So the Brock Information Desk is opens at 9 o'clock each morning. It's manned by one volunteer. The manager of volunteers wants to know a little bit more about how the Brock Information Desk runs. Things like how often clients have to wait before they can talk to a volunteer, how much time is the volunteer idle between clients. So the manager has collected some data. We have a probability distribution for the amount of time it takes to serve customers. So 16% of the time it will take 3 minutes, 29% of the time it will take 4 minutes, etc. The manager has also collected time as far as the time between arrivals. So there's 3 minutes between customer arrivals, 20% of the time, 24% of the time there's 4 minutes between arrivals. So we're going to use these probability distributions to generate our random variates. So the Data tab, Data Analysis, our random number generator. I've set this up for the arrival of 30 different clients. So the number of variables I want is 1. The number of random numbers is 30. I'm doing it from a discrete probability distribution. I'm going to do the inter-arrival time first. So this is my probability distribution. I'm going to use a random seed of, I won't use a random seed, so we'll just let it be truly random numbers. My output range is going to be in column B, so I want it to start in that cell in B12. I say OK, and here I have inter-arrival times for 30 different clients. Now I also need a service time for each of those clients, so I'll get my random number generator back again. One variable, 30 random numbers from a discrete distribution. This time the distribution I want is over here in the service table. And this time my output range is service time, so I'll say OK. So now I've got the time that it takes to serve each of these 30 clients. So this is an example of what's called a time-dependent simulation model. So a lot of the columns in our model are going to be actual times. So our starting condition was that there was no one waiting for us when the desk opened at 9 o'clock. So my first client arrives 5 minutes after that. So I'm just going to put numbers in here to walk through the first client, and then we'll put our formulas in for the second one. So that time of arrival, this client arrives minute 5. Their service can start right away because no one was there ahead of them, so their service will start minute 5. It takes 6 minutes to serve them, so their service end is minute 11. They had 0 wait time, and the volunteer was idle for 5 minutes. So that's really what those columns are describing. So now let's try and figure out formulas. So the time of arrival for my second client, my inter-arrival time is 3 minutes. So that means that the second client arrives 3 minutes after the first client. So their time of arrival is going to be equal to the time of arrival of the previous client plus the inter-arrival time. So client 2 arrives at minute 8. When does their service start? It can't start at minute 8 because the volunteer is still serving the previous client until minute 11. So we can sort of see that the service start time is going to depend on the end time for the previous client and this client's time of arrival, because if this client had arrived minute 12, then they could start at minute 12. But they arrive minute 8, they can't start till minute 11. So we can see if we look at these two different values that our service start is going to be equal to the maximum of, so equals max of the service end of the previous client, comma, the time of arrival of this client. So in this case, that's minute 11. They take 6 minutes as well, so their service end is always going to be equal to the service start plus the service time. Wait time. This client did have to wait. They had to wait. They arrived minute 8. Their service didn't start till minute 11. So the wait time is going to be equal to the service start minus the time of arrival. And we don't have to worry about negative numbers in this case because the service start can never be before the time of arrival. So this client had to wait 3 minutes. In this case, the volunteer was not idle. In the last case, they were. So we have to figure out a formula for idle time. So idle time is going to happen when the time of arrival of this client is greater than the service end of the previous client. In this case, it's less than. So if I took that difference, I would get a negative number. So I do have to protect against negative numbers. So I can do that as we did in the grapefruit computers. I can do it with an if statement. I can also do it as a maximum between the difference between these two numbers and 0. So I'll do it that way this time. So this equals the maximum of the time of arrival of this client minus the end of service for the previous client. If that's positive, then the volunteer was idle. But if that's negative, so I'll put a comma, if that's negative, we want to see 0. So the maximum of that difference, or 0, will work as our formula. So now we have formulas or functions in for all of our columns. We'll copy them down for the next 30 clients. Paste. And copy, paste. Now I have some calculations that I've set up down here. I have the average, so the average wait time for a customer is 1.9 minutes, almost 2 minutes. The average idle time between customers for the clerk is 0.37 minutes. The things the manager had said they want to, that he or she wants to know, is the probability that a client will have to wait. And to calculate that, I can again use the count if statement. So I want to count how many, if I count how many zeros are in this column G, the customer wait time, that will tell me how many times customers didn't have to wait. So that's what this function will tell me. Right? Count if values in that range are 0. If I then subtract that from 30, I'll get the number of clients that did have to wait. And then if I divide that by 30, I get the percent of time that the percent of customers that had to wait. So in other words, 63% of our customers had to wait. If I want to know the percent of time that the volunteer is idle, here, I'm going to take the sum of all of the volunteer's idle times. So the sum of everything in this H column here, that's the total time the volunteer was idle, total time for this simulation, I started at time 0 with client 1. Client 30 has finished their service at time 147. So in other words, the simulation has lasted 147 minutes. So that tells me that if I take the number of minutes that the volunteer was idle divided by 147, I will get the percent of time that the volunteer was idle, and that's 7%. So that's our Brock Information Desk simulation model.